Assalamu alaikum and good evening, sir. Today I will present a presentation which is about 555 timer. Me, Mahfuja Yasmin and my friends Snehashi Shaha, Antar Sarkar Bandhon, Sheikh Salman from AAA department will present this whole presentation. Now the second slide is about 555 timer. The 555 timer IC is an integrated circuit used in a variety of timer, delay, pulse generator, and oscillation applications. The 555 timer IC is very cheap, popular, and useful precision timer device which can act as either a simple timer to generate single pulse or long time delays or as a relaxation oscillator producing a string of established waveform of verifying duty cycle of from 50 to 100%. Now, in the third slide, we will know about the history of 555 timer. Hence, R. Kamenzind designed the first 555 timer IC in 1971 under an American company. It is this design work of his that is most prominent in his distinguished career in the field of integrated circuit technology. In summer of 1971, first design was overviewed the, that used a constant current source and had 9 pins. After the review was passed, hence thought the idea replacing with constant these reduced member pins from 9 to 8. Now in the fourth slide we will know about the pins of 555 timer. In the 555 timer, pin 1 is ground which is used to supply a zero voltage to the IC, where pin number 2 is a trigger pin which is used to convert the flip-flop from set to reset. Pin number 3 is output pin which depends on the amplitude of the internal trigger pulse. Pin number 4 is reset pin when negative pulse is applied to this.
Good evening. Previously, we know about the pins of 555 timer. This time, we know about the basic operation of 555 timer. At first, here we see there are 3 resistors and all of these values are 5 kilo ohm and these resistors are in series mode. Now, there are a input voltage which is VCC and there is a ground. And here we can also see two nodes. In these two nodes, the voltage are divided. At the first node, if we see there are two resistors from this node to ground, and for this 2R is divided by total resistor 3I into the input voltage. Then we find the VTH which is 2 by 3 VCC. And the second node, we also see there are one resistor from this node to ground, and for this here we get 1 by 3 VCC. Now we can see there are two comparator A and comparator B, and these two nodes are connected. First one is connected with the non-inverting point of comparator A and second one is added with the non-inverting point of comparator B, and the other two pins are known as threshold and trigger. From these two comparator, first one output is added with a latch R reset and the other one is added with set. And from this we can get Q and Q bar. Q is directly shows us the output and Q naught is connected with a transistor. In this transistor, the emitter is directly connected with the ground. Here is also a reset when the reset is activated for the active low purpose. And this all about the basic operation of 555 timer. Here we also see a truth table for the latch. In here we can know that where it is active low and where it is active high. Here there are the three modes of 555 timer. One is bistable mode, monostable mode and astable mode. Especially we use most of the time monostable and astable mode. My next friends are talking about this. Thank you.
Thank you, Snashish Orgho. I am Sheikh Salman from the Tripoli department. This presentation based on 555 timer, and I discuss about monostable mode and stable mode and bipolar and CMOS version. Monostable mode, the components which determine the operation are one resistor and one capacitor. The monostable mode is one shot mode. In this mode, the 555 timer has one stable state. Whenever the trigger is made low, the 555 timer switches into the unstable state. And after a certain time, determine the external combination of resistor and capacitor, the 555 timer returns of its stable state. Period to triggering the output is low and is to the stable state. The discharge capacitor Q1 is on, the C1 is bypassed and hence C1 do not charge. Stable mode. The components which determine operation are two resistor R1 and R2 and the one capacitor C1. In this mode, the output of a 555 timer switches between the two unstable states without any external trigger. The feature of the 555 timer can be used to generate continuous rectangular wave. The output is the circuit is a square wave pulse. The capacitor charge through R1 and R2. The during charging phase the output is high. Thus time of the high pulse Th equal to 0.693 C1 into R1 plus R2. The capacitor discharge through only R2 and during the discharging phase the output is low. Thus time of low pulse TL equal to 0.693 C1 into R2. Now I talk about the bipolar and the CMOS version of the 555 timer IC. Hence, our Kamengint redesigned the existing IC to diminish the design flaws. The improved IC was then sold by GSTCI 555 but could not create a buzz like a original 555 timer IC did. The classic bipolar 555 IC version like NE 555 IC uses transistor which dissipate large amount of power and produced high current spikes. Hence, this is ICS could not be used in low power applications. CMOS transistors stands for complementary metal oxide semiconductor and uses a combination of both N-type MOSFET NMOS and P-type MOSFET PMOS enhancement mode. All the PMOS transistors have from input from their either the voltage source or from other PMOS, whereas all the NMOS transistors have an input connected to ground or to other NMOS transistor. An example of the CMOS version 555 timer is LMC 555 produced by Texas Instrument. Now I requesting to Antoshorgar Bandhan to present his slide. Thank you everyone.
Thank you, Sheikh Salman, and I am Antashakar Bandhan from Tripoli department, and this is my fourth semester. This presentation based on 555 timer, and I am discuss about our project fire alarm system using 555 timer. In this project, we use different kind of component like as 555 timer, resistor, breadboard, variable resistor, or potentiometer, capacitor, transistor. Here we develop the circuit on breadboard. Then for turn on this circuit, we use 7.5 volt DC source. Then we use potentiometer or variable resistor for low and the high output. The characteristics of this system is when it detects heat or above the room temperature, the system output will be high and the buzzer or LED will turn on. So using potentiometer when output voltage is low, this time if we provide heat on NTC or thermal resistor, then the NTC shows characteristics which is detecting above room temperature, it provides output high. However, if we provide heat on this system, the NTC provide output high, then the buzzer or LED will turn on. On simulation, we see that when potentiometer is 5% and the temperature is 27 degrees Celsius, which is the room temperature, then the system do not give any output. Then we also see that when we increase the temperature like 50 degrees Celsius, the system provides the output. So for the high temperature buzzer or LED will turn on. In this project, we want to reduce our unnecessary fire accident. So that's all our presentation. Thank you.